Good day, students, scholars, and curious viewers. My name is Mr. SKT, otherwise known as the Super Kuroi teacher. And in this lesson, we're going to be doing law number 2 for Laws of Exponents, division of powers. In one of our previous lessons, we did the first law of exponents, being multiplication of powers. And as you can see, the way that worked is that when you're dealing with the same base and you multiply, you add the exponents. So when it comes to law 2, which is division, since division is opposite multiplication, instead of adding the exponents, you're going to be subtracting, minusing the exponents. So in this situation, you get x to the a divided by x to the b gives you x to the a minus b. So an example here, you have 2 to the 7 over 2 to the 3. Remember, if represented as a fraction, it also counts as division. Since they have the same base, you can apply the second law of exponent, giving you an answer of 2 to the 7 minus 3, which is 2 to the 4. Another example, x to the 5 divided by a normal x. Remember, if you don't see an exponent there, you count it as an invisible 1. So what we're doing is x to the 5 divided by x to the 1, which gives you x to the 5 minus 1, thus giving you x to the 4. Pretty straightforward. There are 3 minor points to indicate regarding this law of exponent, which we will cover with, just like the previous one, this applies to same bases. Same bases operates on each other. So when you have x to the 6, y to the 4 divided by x to the 2 and y, remember, that's a y to the 1, don't forget that. You can fill that in if you feel like it makes it easier for you. But don't have it in your final answer if it just so happens to end up as 1. So the x to the 6 is going to act on the x to the 2. So x to the 6 divided by x to the 2, 6 minus 2, giving you x to the 4. And then y to the 4 is going to act on the y to the 1. Y to the 4 divided by y to the 1, 4 minus 1, giving you y to the 3. So your final answer is going to be x to the 4, y to the 3. Second final point, say it with me, numbers work as normal. I'm not going to really say these ones in future laws because it's going to work the same for all the other laws. But yes, numbers will continue to work as they always have. So x12, x to the 12, divided by 3, x to the 3. The 12 divides by the 3 like normal, giving you 4. But the x to the 12 and the x to the 3 will follow this law of exponent. Doing x to the 12, 12 minus divided by x to the 3, 12 minus 3, therefore the x will be x to the 9. So your final answer will be 4x to the 9. Note the difference. And another example is 4x to the 3 divided by 6x. So you can, in fact, simplify the 4 and the 6. Since it is in fraction form, you can divide both of them by the same number, or the highest number that you can divide them by, which in this case is 2. So as a result, you can reduce 4 over 6 by 4 over 6. 2 goes into 4 2 times, 2 goes into 6 3 times. So you can turn 4 over 6 into 2 over 3. and then you have just the x's to deal with. X to the 3 divided by x to the 1 gives you x to the 2, which will remain on the numerator. So your final answer will be x to the 2x to the 2 over 3. Then the final minor point is avoid negative exponents for your final answer. What does that mean? Say if you had this situation of x to the 2 divided by x to the 5. So apply your normal law 2 division of powers, where you go numerator minus denominator. You go x to the 2 minus 5. This will give you a final answer of x to the negative 3, because 2 minus 5 gives you negative 3. Now this answer is fair enough as it is. It is a correct answer. However, most examiners don't like seeing negative exponents. So what they will do is that they will add an additional instruction for you to leave your answer as a positive exponent. So here you can actually convert this into a positive exponent, but how? This is actually a separate law. This is actually regarded as a completely separate law that I'm showing you in this video. If you have something to a negative exponent, you can actually turn that into a denominator with a positive exponent. So x to the negative 3 can be rewritten as 1 over x to the positive 3. It drops down and becomes positive. And that's pretty much what happens. And that's your proper final answer with a positive exponent. So let's do another example in case you didn't catch that. But then although I have a simpler way, frankly, of doing this. Listen carefully. A quick way to do this, watch this. Here's my example. A to the 3, b to the 4, divided by a to the 6, b to the 2. So I have some that are bigger the denominator, some that are bigger the numerator. So where is the final answer going to end up? Well, since I'm dealing with division, it's going to be subtraction with the exponents. Okay? So what I'm going to do, let's deal with the a's first. I have a to the 3 and a to the 6. So 6 minus 3 is going to give me a to the 3. But where is it bigger? It's bigger at the a to the 6. So that means that a to the 3 that I just did the division for is going to end up at the bottom. Why? It's bigger at the denominator. And then if I look at the b's, I have b to the 4 and b to the 2. 4 minus 2 gives you 2. Where is it bigger? It's bigger at the numerator. So my b to the 2 will end up in the numerator. And there's your final answer. B to the 2 over a to the 3 without having to do any complex negative conversions. And if you look at my initial example, it kind of works. You have x to the 2, x to the 5. You're going to be doing a subtraction. So you're going to do 5 minus 2, which gives you x to the 3. But where's it bigger? It's bigger at the x to the 5, at the bottom. So your final answer is going to end up at the bottom. Let's do a couple more examples, students. Here you can see I actually haven't filled this in because I'm going to be doing these with you. So here I got x to the 4, y to the 2, z to the 3, all divided by x to the 5, y to the 7, x to the 5. I'm going to show you, using that method, how you can simplify this without having to jump any hoops and hurdles. literally all in one step. This not only saves you time, but also is also a quick way of checking your answer. So what I like to do is I like to just draw my division line to begin with. So we have x to the 4 and x to the 5. Okay? So x to the 4, x to the 5. Do the division, 5 minus 4. That gives you x to the 1. But where is it bigger? It's bigger at the bottom. So therefore, that x to the 1 is going to end up at the bottom. That's the x's done. Next one, y to the 2, y to the 7. You have 7 minus 2. 7 minus 2 giving you y to the 5. Where is it bigger? It's bigger at the bottom. So that y to the 5 is going to end up at the bottom. And then you have z to the 3 divided by z to the 5. You do 5 minus 3, giving you z to the 2. But where is it bigger? It's bigger at the bottom. So therefore, the z to the 2 will be at the bottom. But what about the numerator? There's nothing there. What do I put? Do I put 0? No. When dealing with empty spaces for a fraction, you don't put 0. You put 1. So your final answer will be 1 over x, y to the 5, z to the 2. And there you go. And with this also applies when dealing with numbers in your division. So 2x to the 3 over 4x. You have 2 over 4. What's the biggest thing that can go into 2 and 4? The number 2. 2 goes into 2 one time. 2 goes into 4 2 times. So you know you're going to have a 2 at the bottom. And then you have x to the 3 over x to the 1. 3 minus 1, x to the 2. Where is it bigger? It's bigger at the top this time. So therefore, your x to the 2 will end up on the top, giving you a final answer of x squared, or x to the 2, over 2. And that there is a little tutorial on division of powers. So here I have laid out for you, give me a second. Here I have laid out for you a small exercise. Small exercise consisting of 7 questions for you. So here the instruction is simplify and leave your answers with positive exponents. I'm going to scroll down so you get a good look at each one, and then I will ask you, if you wish to do this by yourself, I will give you the signal to pause the video. Okay, students, should you be ready, pause in 3, 2, 1. Okay, let's do the correction now. Right, first one, we have x to the 8 divided by x to the 5. Do the just simple x to the 8 minus 5, giving you final answer of x to the 3. B to the 3, A to the 7, C to the 5, all over C to the 3, A to the 5, B. Remember, if you are not sure, insert that one if need be. So, B to the 3 divided by B to the 1 is going to give you B to the 2. 3 minus 1 giving you B to the 2. A to the 7 divided by A to the 5. 7 minus 5 is 2. So it gives you A to the 2. And C to the 5 divided by C to the 3 gives you C to the 5 minus 3, giving you C to the 2. But don't leave your answer like this. Remember, algebraic expressions have to be in alphabetical order. So Show your answer as a squared, b squared, c squared. Number 3, 8x to the 8 divided by 2x to the 2. Numbers operate like normal, so the 8 divided by 2 is going to give you 4 like 4. And then x to the 8 divided by x to the 2 will give you 8 minus 2, x to the 6. So 4x to the 6. 8 to the 3 divided by 8 to the 7. So you can technically do the 8 to the 3 minus 7 give you 8 to the 4. Or you could do your 7 minus 3, which is 4. Where is it bigger? At the bottom. So your final answer should be 1 over a to the 4. S to the 6, t to the 4, u to the 3, v to the 2. All over s to the 8, t to the 3, u to the 5, v to the 4. This one is your test, is your more of your example, your test, if you have mastered the short method. S to the 6, s to the 8. 8 minus 6 gives you 2. Where is it bigger? At the bottom. So you're going to end up with s to the 2 at the bottom. T to the 4, t to the 3. 4 minus 3 is 1. So t to the 1, where is it bigger? It was bigger at the top. So your t is actually at the top. U to the 3, u to the 5. 5 minus 3 is 2. Where is it bigger? At the bottom. And v to the 2, v to the 4. 4 minus 2, giving you v to the 2. Where is it bigger? At the bottom. So therefore, t over s to the 2, u to the 2, v to the 2. Number 6, 3, a to the 5, b to the 3, all over 15, a to the 2, b to the 7. The biggest number that can go into 3 and 15 is 3. 3 goes into 3 one time, 3 goes into 15 5 times. So you should have 5 at the denominator. A to the 5 divided by a to the 2, 5 minus 2 gives you a to the 3. Where is it bigger? At the numerator. B to the 3 divided by b to the 7. 7 minus 3 gives you b to the 4. Where is it bigger? At the denominator. So your final answer should be a to the 3 over 5 b to the 4. And finally, 10 x to the 8 y to the 10 all over 18 y to the 12 z to the 3. So here I've put two numbers that you can't eliminate one completely. I did that on purpose. The biggest number that can go into 10 and 18 is 2. 2 goes into 10 5 times. 2 goes into 18 9 times. So you will end up with 5 on the numerator and 9 on the denominator. The x to the 8, there is no x on the denominator to do anything with that. So that x to the 8 remains there. You do have to deal with the y. You have y to the 10 and you have y to the 12. 12 minus 10 gives you y to the 2. Where is it bigger? At the bottom. And for z to the 3, there is no other z, so it's going to remain at the bottom. Final answer, 5 x to the 8 all over 9 y to the 2 z to the 3. If you enjoyed this video, please leave a like. That will help it towards trending. Please subscribe, helps me get closer to monetization, and please comment on any topic or section you want me to cover. This is the Super Kuroishi teacher, and I'll see you next time.